Okay, today's lesson is going to be on trigonometry, specifically how right triangle trigonometry is used in physics. Um, with a right triangle, obviously you need one side that has a 90-degree angle. Opposite of that 90-degree angle is what's called the hypotenuse. If you define one of the remaining angles as theta, then adjacent to that is called the adjacent, and opposite of that is called the hypotenuse. Okay. Now, if you have, like, for example, a circle, and you take the circumference and divide it by the diameter, it will always be the same ratio. It will always be pi, no matter how big the circle is. The circumference divided by the diameter will always be pi. In a similar situation, for a triangle that has an angle of theta, let's say theta is 30 degrees, and we take this opposite side and we divide it by the hypotenuse. No matter how big that triangle is, as long as this is 30 degrees, it will always be 1/2 the ratio. By definition, this is defined as sine of theta is equal to opposite over the hypotenuse. As you can see, in the case I just gave, if this was 30 degrees and this was 5, then this would have to be 10. If this was 30 degrees and this was 10, this would have to be 20. Now, obviously, all bets are off as you change the angle. So that's why you have to have a whole bunch of different ratios, each one being different for each angle. Now, obviously, you can compare other sides as well. Cosine of the angle is where you take the adjacent side and divide it by the hypotenuse. That's defined as the cosine. And you also have this situation where you're comparing the opposite side over the adjacent side. That's called the tangent. Okay. Now let's see how we can use this. Let's say the sun is shining on a building and it's casting a shadow that extends out from the base of the building 67.2 meters. And it makes an angle of 50 degrees with the horizontal. And we're interested in finding out how high this building is. Since we don't know the hypotenuse, we would have to use the tangent. Because the tangent is going to be comparing this adjacent side to the opposite side, and we already know the angle. So if we put the numbers in, and then we actually solve for the opposite side, we would get the tangent of the angle times the adjacent side. Gives us the answer. Now, when you plug this into a calculator, you've got to make sure that you actually do it correctly. So I would actually, try this on your own to make sure it does come out to the correct answer. Okay? All right, let's try one on our own. Or we'll try another one, actually. A truck drives up a hill at a 15-degree incline. If the truck has a constant speed of 22 meters per second, what are the horizontal and vertical components of the truck's velocity? All right, so we have the situation where we have, let's see. A velocity that's 22 meters per second at an angle of 15 degrees. And what we're trying to do is find this opposite side component and this adjacent side, or this component. Okay? So let's do the opposite side first. The opposite side deals with the idea of sine. Sine of the angle is equal to the opposite over the hypotenuse. Okay? Or, in other words, the opposite side is equal to the hypotenuse sine of the angle. If we put the numbers in, we have 22 meters per second sine 15 degrees. And when you plug this in your calculator, it comes out to be 5.7 meters per second. Okay? And if we do the adjacent side, this would be the cosine. Cosine of the angle is the adjacent over the hypotenuse. Okay, so the adjacent side oops, sorry about that, would be equal to the hypotenuse cosine of the angle. So this would be equal to the adjacent side, 22 meters per second cosine 15 degrees. And I believe this comes out to be 21 degrees when you put it into your calculator. I mean, it's going to be 21 meters per second. So what we've done here is we've taken the initial velocity and broke it into its components, its vertical component and its horizontal component. In other words, we've taken a vector and broken it into its sides. All right, but let's say we know the sides, but want to find an angle. This is where we would use the idea of sine, arc cosine, and arc tangent. Basically what you're saying here is to the calculator or your computer is, if I know this ratio, if I know the ratio of the opposite over the hypotenuse, what angle does this work with? And going back to the initial one we had talked about, where we said the sine of 30 degrees is always going to be 1/2. If we look at this and we put 5 in here and 10 in here, what angle does that work for? It only works for one, which would be called the angle of 30 degrees. Now there's also the arc cosine and the arc tangent. Excuse me. Now let's see how we can use this. Let's say that you wanted to find out what this angle is here that formed with the water, okay? And we knew that this side here was 14 and this side here was 2.5 meters, and we wanted to find out what side or what angle this would work for, okay? Since we don't know the hypotenuse, we would actually have to use, once again, the tangent. And since we're looking for the angle, we're going to be using the arc tangent. So just plugging in the numbers, it comes out to be 9.13 degrees. One thing I failed to mention is the fact that this equations that we'll be using in the initial part of the book, or the chapter, deals with degrees. If you can't use radians and get the correct answer, in other words. Okay. All right, so far we talked about the idea of knowing one of the sides and one of the angles and be able to find the other information. We've been able to take two of the sides and finding out one of the missing angles. Now we're going to say, forget about all the angles. We know it's a right triangle. Can we figure out the third side? And this is what we'd be using Pythagorean's theorem for. It states that the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other two sides. All right, so you have, for example, this relationship that we keep on looking at. So this side squared, the hypotenuse squared, would be equal to the opposite side squared plus the adjacent side squared. All right, so how can we use this? Now, for example, let's say we have a vector that's 23 meters to the right, and then the one that's 45 meters straight up, and this makes a 90-degree angle. And what we'd like to know is, using this x and y components, what is the resultant vector? Okay, what is this light green vector? What's its length? Okay, well, to find that, we would use Pythagorean's theorem. All right, so we take the opposite side, which is 45 meters, we'd square it. The adjacent side, which is 23 meters, square it. Obviously, take the square root of that, and it comes out to be 2,554 meters. Now, obviously, this only had 2 sig figs, this only had 2 sig figs, so we really should be rounding it to only 2 sig figs. Okay, that's pretty much it for using sine, cosine, and tangent. We're going to be applying that later as we learn more about scalars and vectors.